The topic of this video is present value. In economics and business, we must often compare values at different points in time. This video will explain why a dollar today is not equivalent to a dollar next year, and how you can use present value calculations to make comparisons of value at different points in time. Let's start with an example. Suppose your aunt says she will give you $100 for your birthday, but she can only afford to do so every 2 years. She gives you the choice between receiving the $100 this year or the $100 next year. The question is, are these equivalent? Well, if you receive the $100 today, you have the option of putting it in the bank and earning interest. Suppose the nominal interest rate is 5%. Then you take your $100, you put it in the bank, and next year you'll have $105 since there was a 5% interest rate. So $100 invested today turns into $105 next year. We call 105 the future value 1 year from now of $100 today. So let's ask the question slightly differently. What amount received today would be equivalent to receiving $105 next year? That is, what is the value of x that solves the following equation? X times 1 plus the interest rate equals 105. Well, rewriting, we have x equals 105 divided by 1 plus the interest rate. And x is known as the present value, or PV for short, of the 105 received next year. So the present value is equal to 105 divided by 1 plus the interest rate. So we discount the future value by dividing by 1 plus the interest rate. As another example, let's calculate the present value of 105 received next year when the interest rate is instead 6%. In this case, the present value is $99.06. So with an interest rate of 6%, the present value of $105 received next year is $99.06. As the interest rate rises, the present value decreases. For example, if the interest rate is 10%, then we're dividing by 1 plus 0.1, we get a present value of $95.45, which is less than the present value when the interest rate was 6%. Let's go back to the question posed by your aunt. Which do you prefer? $100 today or $100 next year? As long as interest rates are positive, $100 next year is not as valuable as $100 this year, because you will have given up the opportunity to earn interest for a year. Thus, you should choose the $100 today. And if your aunt accuses you of being impatient, say, no, this has nothing to do with my impatience. This just makes good financial sense. Now let's consider 2 years ahead. How much invested now would be equivalent to $110 received 2 years from now? Well, if I invest X dollars for 2 years, I start with X, I put it in the bank. At the end of 1 year, I have X times 1 plus the interest rate. But then I roll it over, let it compound, keep it in that bank for the second year, and at the end of 2 years, I have the amount I rolled over times an additional, or 1 plus the interest rate. So writing that out and putting it a little bit more succinctly, what we want is X dollars times 1 plus the interest rate squared, since we have 2 years of compounding, equal to $110. Again, this X is just the present value. So the present value of $110 received 2 years from now is 110 divided by 1 plus the interest rate squared. Let's think many years ahead. What is the present value of $999 received T years from now? T can stand for 5 years from now, 10 years from now, 20 years from now, 50 years from now. In other words, what amount received today and invested with compound interest would give a future value of $999 T years from now? That is, what is X in the following equation? Here we have 1 plus the interest rate raised to the power T, for the same reason that we had 1 plus the interest rate raised to the power 2 when we had 2 years. If we have T years, we have T periods of compounding. The solution of X is the present value. So the present value is $999 divided by 1 plus the interest rate to the power T. Now let's think about a stream of revenue. Suppose a machine will yield a stream of revenue of $3,000 per year for 5 years, starting this year. What is the present value? Let's start by plotting out a timeline. So this year we get $3,000, but then we get an additional $3,000 for 4 years after that. Well, the present value then is equal to, first of all, $3,000. We don't have to discount that since we receive it this year, plus the $3,000 next year divided by 1 plus the interest rate, plus the additional $3,000 the next year divided by 1 plus the interest rate squared. Again, we're thinking about the compounding over 2 years, and then all the way up to the 4th year, where we have 1 plus the interest rate to the 4th. So quiz yourself. We need to calculate the present value of an investment project that generates $1,000 each year for the next 2 years, starting next year. What formula should you use to calculate the present value? Well, the present value should be that initial $1,000, but since you get that next year, you have to discount that back to this year. That's why you divide by 1 plus the interest rate. Then you take the $1,000 received 2 years from now and discount that back using 1 plus the interest rate squared. And then we sum those two since we get $1,000 for 2 years. How about real versus nominal? Should you use the nominal interest rate I or the real interest rate R to discount? Well, it depends on the circumstance. If you are discounting nominal values, use the nominal interest rate. If you are discounting real values, i.e. inflation-adjusted values, use the real interest rate. So to summarize, because we can borrow and lend at positive interest rates, a dollar received tomorrow has less value than a dollar received today. We can compare dollar amounts across time by calculating present values. As interest rates rise, the present value of a future amount falls. Use nominal interest rates to discount nominal values and real interest rates to discount real values.